Well, welcome to this online revision session for AQA FP3, which we're looking at the June 2011 question 6 on the solution of second order differential equations. Well, as you can see, we're given a differential equation, and in this case we're given a substitution in part A which transforms this second order differential equation into a first order differential equation. Then in part B we solve that first order differential equation, and then using the substitution we get back to a solution for the second order differential equation that we were originally set. Well, let's see how this question is going to work out then. We know initially that u is equal to dy by dx minus 2x. So if we differentiate both sides of this with respect to x, we will get du by dx is equal to the second differential of y with respect to x minus 2. That's the differential of 2x. So now we can substitute these two parts into the second order differential equation. So substituting those in, we will have x cubed plus 3, and we're replacing d2y by dx squared, which we've just found when we rearrange this expression is du by dx plus 2, and then we got minus 3x squared, and that's multiplied by dy by dx. So again, if we rearrange this, this will become u plus 2x, and that will equal 2 minus 4x cubed. Well, now we can multiply out these brackets and hopefully see what we got. Well, we can see initially that we have the x cubed plus 1, which if we look at the answer that we're working to, we require being multiplied by du by dx. And then we got x cubed plus 1 times 2, so that will give us plus 2x cubed plus 2. Then if we multiply out the second bracket here, we're going to get minus 3x squared times u, and then we get a minus 6x cubed, and on the right hand side we've still got the 2 minus 4x cubed. But now we can see some of these will disappear, because on the left we got a 2 and on the right we got a 2. On the left we got 2x cubed minus 6x cubed, which is minus 4x cubed, and we got a minus 4x cubed on the right. So again, those will cancel out, and so all we're left with is the x cubed plus 1 times du by dx, and we've got a minus 3x squared u, so if we take that across to the other side, that becomes plus 3x squared u, which is the required answer. 4 marks on this part. Well, the 4 marks will come from, well, let's see, what have we got? Initially we did the du by dx, differentiated this, so again knowing that's what we had to do to generate the second order d2y by dx squared, and doing that correctly gives you a mark. Then substituting everything in to the second order differential equation that we had, doing that correctly will give you a mark, and then reducing it down to the final answer will give you the 4th mark. So there's your 4 marks in part A. Now part B, we're now looking for the general solution of the second order differential equation, so we're going to have to solve initially the first order differential equation. Now we should recognise here that we got x cubed plus 1 and 3x squared, and everything's multiplied together on each side, so we can separate the variables, which is a basic technique for solving first order differential equations. So if we separate, we're going to get on the left hand side the integral of 1 over u du, and that's going to equal the integral of 3x squared over x cubed plus 1 dx. So on the left hand side we know the integral of 1 over u is the ln function, and on this side we should recognise that the top, the 3x squared, is the differential of the bottom, the x cubed plus 1, so this again will become ln of x cubed plus 1. And if you don't know that, the other method would be to substitute u equals x cubed plus 1 and go through this method of substitution to get to this answer. And then we got plus a constant. Now since we have ln on both sides, the sensible constant to put is ln of some constant a, because then we can add these two log functions, and we know that when we add, that's the same as multiplying the two terms. And then if we do the inverse of ln on both sides, i.e. the e function, we will end up with u equals a multiplied by x cubed plus 1. So that takes us to our solution to the first order differential equation. That's u in terms of x. So now we need to use the substitution. Well, the substitution told us that dy by dx is equal to u plus 2x. And so in this case, we now know what u is, so this becomes a x cubed plus 1 plus 2x. And again, if dy by dx is equal to this function of x, if I integrate both sides with respect to x, I know that y will equal, well, it's a constant times the integral of x cubed, which is x to the 4th over 4, the integral of 1, which is going to be x, and then the integral of 2x on the outside is x squared, and then I must remember, having integrated, that I now need an additional constant, let's call it b, on the end. Right, well, we get 8 marks for doing this. So where did we get the 8 marks? Well, firstly, for separating the variables correctly, well, we'll get 1 mark. Then working out the integral and ending up with the ln of u and the ln of x cubed plus 1, you'll get 1 mark for each of those. And then writing your constant as ln a to be able to simplify u down to a x cubed plus 1, that will give you a further mark. Having got that, we then get a method mark for then applying the fact that dy by dx is u plus 2x and then substituting in, and then a method mark for ending up with the required constant in both parts here, having done the integration, and then an accuracy mark for having the correct solution at the end of it. Hopefully you found that solution helpful. For more solutions and help with your revision, please go to the Further Maths Support Programme website.